Okay, so unrelated to anything else, but I just thought was a kind of a fun topic is Shiny. Okay, so you type in R Shiny, and that takes you to here. And there's a textbook that you can read for free called Mastering Shiny. So if you type in Mastering R Shiny, it'll take you to masteringshiny.org. This is the textbook that you can use, and this lecture is based largely in part on some of the content from here, and you can read the entire textbook for free, and it's a very good reference. But anyway, let me just show you what Shiny is. Shiny is a way for you to kind of create these interactive web apps, all right, that kind of visualize data or do some quick data analysis. And so if you just go to shiny.rstudio.com, they have an example little web app here of what Shiny can do. And it's kind of cool. And if you were to try to build a web app yourself, it's such a pain. Okay, I don't know if anybody had to try to do HTML development or web development themselves, but there's a lot of stuff. There's you got HTML, you have CSS, you have JavaScript, you have all of these things, and there's all these different web frameworks, and if you want something simple, it's okay, but anything fancy, it becomes a headache. All right, and I would say Shiny is starting to become fancy. So anyway, here's an example of the interactive nature of this. Is here's a little drop down, and you can pick different data to display. Okay, and then with this, you can you have a little checkbox, and you can display a trend line, and this trend line you can kind of adjust some of the values here. So let's if I do education and I have a small smoother span, and you get this it gets wiggly, and if you expand, then it smooths out. Okay, so how does this work? All right, so anyway, that's kind of what a Shiny web app will look like. And I just thought, well, maybe we'll talk about how to build one of these things. And it's quite simple. It's kind of like, once you understand that there's different pieces that work together, it's useful. Okay, so anyway, the most important thing is to know the reference documents. Okay, so if you go to Shiny, you'll go to reference. All right, and then we'll just go to the latest version, and we'll look at the function reference. And this function reference will contain pretty much all of the different pieces that you can kind of put together into creating a Shiny app. Okay, I'm going to do some live coding here, and that's always risky. I'm always going to be making some mistakes, and I'm going to get stuck and try to figure out what I'm doing wrong here. Okay, so anyway. I'm just going to go to, from RStudio, I'm going to go to New File, and we're going to do Shiny Web App, okay? Or from the drop-down, we'll do Shiny Web App. All right, so I'm just going to call this Class Demo, and we'll create this. This one's already, the last one I called was Class Demo. Okay, all right. Got to come up with better names. We'll call this Class Demo 2. It's like the worst name to create something if you already created something else. Just append the number 2 to it. That's not a good strategy, but that's what I just did. Okay. And kind of like when you create an R Markdown app for the first time, or R Markdown document from the default, it creates a template with stuff pre-filled in. And so anyway, when you just say make a new Shiny web app, it's going to come in with stuff already there. And we'll just take a look at what's there, and then we'll try to build off of it, expand on it, and things like that. So one thing you can do right away is you can just click Run App, right? So you create a new one, and it comes with stuff already in there. But we'll just go ahead and click Run App, and this is what it looks like. Okay, it says Old Faithful Geyser Data, we have this thing over here, and we have this thing over here. This over here, we got the histogram of X, and over here we got the number of bins, and I can use the arrow keys, and I can change the number of bins, and we get something that looks like this. And we go, oh, okay, get this bimodal distribution. You know, we can reduce it all the way down to 1 bin, and you know, 2 bins, 3 bins, 4, 6. Okay. All right, so what does... All right, so as I change this, this is what it looks like. You can also open it in your browser, and it opens up in your web browser as well, okay? And it's still the same kind of interactive thing. Okay, so that's what a Shiny web app looks like. So let's look at the code that produced this, okay? And so it produced everything. There are basically 2 parts in designing a Shiny web app, okay? One is, what does your page look like? Okay, that's what this is. This is called the UI, the user interface. This is how the user interacts with the data, okay? And they're going to interact with the data here with a little slider, okay, numeric slider where they can pick the number of bins, and then it reacts and it outputs a histogram, you know, reflecting the changes requested by the user, okay? So one part of the Shiny app is the UI side, and then the other part is what happens in the background, what's going on, okay? And then so basically your Shiny app, when you create it, it's gonna say load library Shiny. You're gonna have a UI declaration. You're gonna have a server declaration, and then when it says run the application, it's gonna just be run the Shiny app. UI equals UI, server equals server. So let's just take a look at what's in the UI part, okay? The UI part, almost all of these will have fluid page because the page is kind of this, is how it's going to work. Okay, we've got the title panel, and so our title panel is Old Faithful Geyser Data, and obviously we can change that to whatever we want it to say. And the layout for our page, we have the sidebar layout. The sidebar layout, I think, is a pretty good choice. Basically, you have stuff in the sidebar, and you have stuff on what they call the main panel. So on the sidebar, you might have input options for the user, little different sliders, different input things that you can have. And then over on the main panel will be the output. So in our case, we have a histogram, a plot being output. But you can also have a table being output, text being output, things like that. So as far as our sidebar goes, we have one input. It's a slider input. So this is what we have. We have sidebar layout. On the sidebar panel, we have one input, and it's a slider input. On the main panel, which is on the right-hand side, we have a plot being output. Okay, the slider input controls the number of bins, so we give it a name bins, and the label is number of bins. That's what we see here, number of bins. This is the slider input with a min of 1, maximum of 50, and the default value is 30. And then on the right-hand side, we have a plot being output, and the name of that plot is the distribution plot. So that is how we've defined the UI, okay, the user interface. In the background, the way it works is the server renders the plot, okay? So it's gonna render the plot. The render plot gets stored in dist plot. And so what the server is generating is gonna be, it's generating this histogram over here. So how is it generating that histogram? Well, the command to generate the histogram is histogram of X, which is our second column in the Old Faithful data. And the options that we're messing with is how many, where the breaks are located, okay? And the breaks are going to be located at these bin locations. So the bins creates a sequence from the minimum of X to the maximum of X. And the one thing that we are taking from the UI part, okay, this UI under the fluid page, we're taking the slider input, which has the label bins. So we're going to go input $bins. Input $bins gets taken from the UI, and it's going to get plugged in here. So it starts off with input $bins being 30, and then as I change this, input $bins changes to what, 16 or whatever, and that gets used to determine where the breaks go in this vector called bins. And once we have that, it's going to draw the histogram with this new with these new values. The color is dark gray, the border is white, and it outputs as such there. Okay. And so those are the pieces that that make this web app. Okay. So what if we wanted to do something a little bit different? Okay. So so let's say I wanted to actually see where the breaks are, where the breaks are being located. So I can add additional piece of thing to the main panel. So right now here I have plot output. Let's add some text output. Okay, so what you'll do, I recommend going to the Shiny reference, and when you go to the Shiny reference, you'll see all of the different pieces, the different things you can have, right? So you have the UI layout, and right now we're doing the sidebar layout, and that comes with the sidebar panel and main panel, but there's different layouts you can have for your page. I'm fine with this layout, but what I want to do is I want to add some outputs, okay? So this time, so you've got UI inputs, but let's add some additional output here, okay? And so for the UI output, we're gonna ask for some text output, or in this case, verbatim text output will be kind of like in typewriter font. So we'll just ask for some verbatim text output, okay? So we're gonna call verbatim text output, and I'm just gonna use output ID, okay? Oops, so actually I want verbatim. Okay, let's call verbatim text output, and we'll call this break locations. All right, so what I need now is I need to create something on the server side called output $break locations. All right, so I need to create that because it's going to be looking for that to put in the verbatim text output here. Okay, so over on the server side, I'm going to create something called output $break locations. Okay, so this is what we're going to create, and whatever is being produced here is going to show up in this location over here. Okay, so we have to create something called output break locations. And so what we need to do is we need to generate some text. Okay, what is this text we're going to generate? So this, we're going to look at the reference, and so we have rendering, and there's different things you can render, but we're just going to do render text. Okay, so we need, when we update, say, the number of bins, we're going to update the text that appears here. So we're going to call render text. So I'm going to call render text. Okay, and we have this function. And so inside here, I'm going to put in a curly brace to put in some lines. And basically, I just want these lines of code here. Okay, I just want the bin locations. Okay, and this is kind of like a function. And the last line of your function is what's going to get returned, and that's going to be the thing that gets rendered. Okay, so let's go ahead and try this. Okay, so we're going to just take the min, the max of x, input bins, and when I do this, we'll go ahead and run this. Okay, and the very classic R error, object x not found, shows up. Okay, so what went wrong? Okay, well, inside here, I'm referencing min x and max x, and it doesn't know what x is. So I actually have to include this line. Okay, so I have to say, okay, look at the old faithful data. Okay. And so we'll reload this. Okay, and so now it's running. Okay. Maybe I'll ask round bins to 2 decimal places or something. I don't know. Just make it a little easier to read. Okay. So this is what we have. And so we can see, all right, if I change this to 1 bin, we got 43.96. 2 bins, these are the locations of the breaks, so on and so forth. Okay, so now this text is being output here. All right, is that okay? So the way we just added some stuff. Okay, if you wanted to, instead of render text, you could do you could create a table. Okay, so instead of verbatim text output, actually, let's go to our reference, and as far as outputs go, wait, where's the table? Render data table. Table output. Okay, we're going to ask for, I think that's what I want, right? Okay, so this is a little risky because I'm not, I think I do table output, and we're going to call this break table. All right. I'm not sure. Okay, so I'm going to create output $, what did I call this? Break table? I hope this works. This might not work. Okay. And we'll call render table. And what do we want to do? Let's create a data.frame of bins equal bins. Let's just go ahead and take this same code and put this right here. All right, we'll try reloading that. Let's see if that works. Okay, and so now the table appears here, indeed. Here, let's create a column. So we'll call it ID or number equals sequence length bins. And we're making a data frame with that. Oh no, sequence. What's the function? Sequence length? What? Am I a dummy? All right, let's just do 1 through bins. Okay. Bad habits. Okay. Oh no. Arguments imply differing number of rows. Oh, 1 through length bins. Let's see. There we go. Okay. Ta-da. Number of bins, etc., etc. Okay, so you can generate your table like this. Okay, break table, render table, and you have that. Is that okay? So I'm just kind of building up this thing. Okay, what if we wanted to have another input? So instead of just being able to change the number of bins, what if we want to be able to change the color of our histogram? So let's add, after our slider input, let's have another input thing, okay? So let's go to our help, and let's see what kind of inputs we can have. UI inputs. All right, I'm going to do text input, okay? We'll do text input. And what do we do for text input? Okay, input ID, label, value. Okay. So we'll do input ID. Input ID will be, we'll call this fill color, and the label that we put on the page will be fill color, and the value will start off with dark gray. Okay, and then we need to reference the fill color here. So we're adding a text input. And so what we want to do is in the plot, this dist plot that we're going to do, we're going to reference the input $fill color. And we'll change that, okay? So under histogram, instead of color dark gray here, we'll do input $fill color. Okay, and so whatever appears in here, right now it's the word dark gray, that's going to get put in here. So we'll try this out. I hope this works. Okay, so I've got dark gray, and then I can change the fill color. I can type in red. We'll get red. I can type in blue. If I type in something wrong, okay, aqua, it gives me an error. It says there's no invalid color name aqua. But I don't know. What do we have? We have navy. Huh?
Does it take rainbow?
I don't think so. An invalid color name. What are the R colors? R colors. We'll go R named colors. That's hard to read. Fire brick 1. Fire brick 1. Fire brick. Is there a difference between 1 and 2? Fire brick 2? Fire brick 1. Okay, I don't. What's that? Okay. What's the difference between red and fire brick? Oh, okay, there's a difference there. Fire brick and fire brick 2. Very subtle, very subtle. Okay. So anyway, so that's a possibility. Okay, so that's a text input. Okay, what if we want a different kind of input? Let's see. We have select input. Okay, select input. Okay. So this will be, we'll call this line color. And the choices will be a list of, we'll have black, white, yellow. Okay. I think. Is that right? List choices. The name. Okay. And then, all right. And then the border will be input $line color or line col. I hope this works. Okay, so we have this, and you can do. All right. So these are like the different choices you can do, right? So here you can do fire brick and yellow. Oh no, that's like our mortal enemies, right? Okay, so let's what is sky blue? Okay, a little bit more world at peace here. Okay, it does look green in the projector. Okay, all right, but anyway, that's so you can. You can see how simple it is to just kind of like piece these things together, and you can say, well, I want to have this kind of input and that kind of input and things like that. And you know, there's a wealth of resources out there. Okay, now one thing that we've done here that is not great, okay, is that we've duplicated this code, right? In each of these things, I said X is faithful, comma 2, bins is this. And this is just bad practice, right? Anytime you're like copying and pasting the same code, multiple locations, we don't want to do that. So So one thing is what we can do is we can take this x out and we can just put it on the server side, and we can make x a value that we can reference here, okay? So then we don't have to have this same line duplicated, okay? And x this is a static value. It's not going to change based on, like, the values inside the faithful data set aren't changing based on user inputs. However, the number of bins or the location of the bins do change where based on the user inputs. So we can move the bins out to here, but because it depends on what is happening inside from the user input, we need to wrap this up in something called a reactive thing. Okay, so we're going to say this is reactive. Okay, and like a function, we're going to say calculate this. This is going to be the value that gets returned, this sequence. Okay, and so the distinction here is faithful doesn't depend on user inputs, but this thing, where the locations of the breaks are, does depend on user inputs. So we need to wrap this inside of a reactive kind of container here. Okay, a reactive part. Okay, all right. And so now that I have bins there, we can. I'm going to get rid of this, and I'm going to get rid of all of this stuff. Okay, and so now we can do this. Now, when I do this, I'm going to get an error. Okay, I get all of this stuff. Okay, unused argument. Okay, all right. Well, something's going wrong. Okay, so one thing we need to do is for bins, anytime we reference these values that are being generated here, we now treat this like the output of a function. So we're going to call bins parentheses. Bins parentheses. Length bins parentheses. Bins parentheses here. Okay? So we're going to do that, and hopefully now it's working. Okay? So rather than having to duplicate those lines of code everywhere, we can create these values that get reused, the bins. We put that inside of a reactive function. And so now bins becomes kind of a function that outputs the same values every time it's called, rather than having to regenerate all of this stuff. Okay, so we set bins to be reactive, and now anytime I need those values, I call bins the bins function, which is going to generate those things here. Okay, so we have that. I was messing around with this, and I created this little app. Let me go ahead and run this. This is like a least squares, illustrates least squares regression. And so here I have just 4 points. X is 1, 2, 3, 4, and Y is 1, 3, 2, 4. And right now I have this line, intercept 0, slope 1, and it fits like this. And it says, okay, these, it's predicting for x1, it's predicting 1, x2, for x is 2, it predicts 2. And it says the residuals here, you have a positive residual 1, a residual negative 1. And when you square the residuals, you get these squares here. And this is to kind of show you that, like, okay, you can change the location of your line, and your squared residuals will change, and so on and so forth. And so this is to illustrate kind of how least squares regression works. And the goal is to try to find the line that minimizes your squared residuals, right? And I have this button for fit OLS, and when I do that, it says, okay, the slope is 0.8 and the intercept is 0.5. This is where the values we would predict. These are the residuals and the squared residuals, and the sum of squared residuals for our plot becomes 1.8. And this is going to be the smallest amount of sum of squared residuals, and any other value we try to choose will increase the sum of squared residuals. Okay, if I choose a different intercept, it changes. Okay, so anyway, this is just one thing I created. If you look at the pieces that went in, I had two slider inputs, one for the slope, one for the intercept, and then I have this action button, which is fit OLS. The output has a plot output, a table output, and some text output. And then inside I have the data set being calculated reactively based on the slope and intercept that come in. We say, it's going to change our predicted values. We change our residuals, our squared residuals based on that. For the plot, the coordinates of the squares, the rectangles, that was kind of a pain to figure out, but I figured it out, and I created the data set based on that. And then when you click the button for Fit OLS, on the server side you say observe event, and this is basically when the button gets clicked. That's when that will trigger this thing, and it's gonna. I said when it observes the event, update the slider inputs and stuff like that. Okay, and then it creates the regression, it creates the tables and all of that. So anyway, it's just different pieces going together. A nice thing about Shiny is that it's creating web pages, and you can publish the web pages. Okay, and so you can go to shinyapps.io. You can create a free account. Okay, you can just create a free account, and you can create up to 5 little applications here, and so on and so forth. You probably don't need to sign up for a professional account, not yet. Okay. And so I've created just like a free little account here, and I published. Login failed. Okay, there we go. Okay, so I took this little least squares regression thing that I made, and I published it. Okay, and it's actually quite simple to publish your app. Okay, in RStudio, there's this little button here that will publish your least squares regression app. Okay, and all you have to do is you go to manage accounts. And I published it from my home computer. So my home computer, the desktop at home, has the account. But basically, under options, your global options, you go to publishing, and you can say connect a publishing account, and you can sign up for shinyapps.io account. And when you go to shinyapps.io, under your account, there's this page tokens. Okay, I'm not going to show you my secret password token, but you go there, and it's it has this complicated string that you copy. Okay, you click that, you copy it, you paste it into RStudio here, and then you'll click connect an account, and then that will create the account that you can do. And then all you have to do is you click this little button. Okay, publish the application, and it will publish to the internet. And so now anybody on the internet can go to smileschen.shinyapps.io, and it will fire this up. Okay, and it creates a little app, and this is on the internet, not just running locally on your own local machine. Okay. Okay, something's wrong, but anyway, that's how it works. And so if you wanted to create little projects and stuff, put things in a portfolio to show prospective employers and whatnot, Shiny apps are kind of a cool little fancy little thing, and they're kind of fun also to build up. So anyway, I just thought that was a neat thing to do. Okay. That's all I have for today. I didn't give you any. We'll just scratch the view quiz for today. But thank you for attending. No class on Friday. I'll be around for office hours. So truly, good luck as you study for the final exam. It's been a pleasure being your teacher. I hope you enjoyed the course, and yeah, and I hope we see each other in the future for perhaps either 102B or 102C or 101C. I'm teaching that in the summer, so whenever you guys are taking these things. Wherever it is, I wish you guys the best. We'll see you guys next week for the final exam.
Thank you.
All right, thank you.
Thank you.